All right. So the number one thing, if you want a copy of this, I can send it to you. I think this should be free. We shouldn't have any problems with copyright because we're using this for educational purposes. So number one, it's public space. It's one of the most important parts of a city. So we have the streets, and what comprises the streets. So you have your highways, your major roads, and your minor roads. So over here, let me minimize this. Our example is New York City because this is what the book was about, New York. So you can see how the different highways connect the different areas of the city. You have the major and minor roads. Let me just bring up a map of Cebu City for comparison. So in Cebu City, we have our major roads. I don't think we have like a highway because all of our roads are not big enough. Compared to Manila, let's over here. I think they really have some highways. So if we go to satellite images, highway would be something like this, something with at least more than 3 lanes of road. And the main sort of, for me anyway, the definition of a highway, it means like you can travel without stopping from point A to point B. So if there's any like stopping, like even like for a few minutes, that would what do you call this? That piece of infrastructure wouldn't be called a highway, but most likely be a major road. So that's the whole purpose of a highway. No traffic lights, no pedestrian crossings. The main purpose is to like connect long distances in an efficient amount of time. Okay, so that's streets. Next, you have your street light infrastructure, your traffic signals, your pedestrian lanes, and then some interesting note here, like split facing. How do they control people? Like making sure that pedestrians are safe while cars are moving. So that's like an important thing for like city planning. Traffic cameras, something that I think we are starting to have in Cebu. I think Mandawi has a lot of traffic cameras. Not so sure about Cebu City. And then what can planners and basically city planners and town planners do with this data, and traffic engineers, is that they can advise different programs and policies to improve traffic movement. So over here, it's a little bit blurred. Just confirming, can you guys see? Excuse me. Klaro ra ba ang diagram?
Yes, sir.
All right. So over here on the left is before their program or their intervention, and these are names of streets. So W54 Street, W53 Street, and then you see here on the left side, W54 Street had a speed, which is over here, of 2.0 to 2.9 miles per hour. So that's slow for them. And then after the Through Streets program, it increased to 4 to 4.9 mph or miles per hour. So this kind of data, they're always monitoring, constantly evaluating to make sure that the speeds are their target speeds are achieved. So they don't want people like getting stuck in some places, and like some places are like it's over kanang imbalance bitaw. So some places are slower while others are faster. And then you can sort of see this with the Google Maps feature, the traffic feature. And then you can see, at least in the Cebu area at this time, because this is live, if I turn this off, the only option is live. Oh, we have typical traffic, so that's great. Let's say today is Wednesday. Let's see, what does Wednesday traffic look like? At what time is it? 8 a.m. That's like peak hours. So you look at the map over here. Not much people going from Cebu City to what is this place? Balamban up here. But if you look at the Talamban Road over here, that's Bakayan, Talamban, you see parts are green and parts are orange, meaning slow. So that it ranges from fast to not so fast. But no red areas, at least typical traffic. This could be pandemic data or pre-pandemic data. I don't know how they monitor this. Maybe they have like cameras. This is something that could be researched on, like for those interested. And I just realized there's a typical traffic button there. Oh, I only thought there was like live traffic. This is live traffic right now. So you see parts of capital site in dark red are slow. So we might have cameras in Cebu City after all. I'm not really sure. Or like they have like like the traffic helicopters, the street people, not street people, like the CTOM, people on the street monitoring the traffic situation. So this is something like very interesting. And then sort of to connect this with your design, let's look at Ayala Center Business Park. So what's happening? Your site is here. Let me double check. Okay, so your site is over here. Notice that the traffic being monitored is to the north of your site. And it's almost always green here in Mindanao Avenue. So a lot of cars will be passing through. Most likely the cars going to your site will be using the Bilaran Road. So they'll take a left or right turn here, down Bilaran Road into your site. So let's take a look at typical traffic. So this could be something you can add to your research, like, maybe I can make my building more efficient, like making your parking or like your turning radius more wider to make it more easier for cars to come in, and then sort of reduce the congestion in your area. But for the most part, I think this area near your site has a decent, what they call this, decent to kanang, as with relation to traffic speed, it's like fast enough. There's not much congestion going on, especially typically during this time, like 8 a.m. Let's look at around 5 p.m. So let's see, any changes? Not much changes. How about different days? I think that's just like the typical traffic. But live traffic, let's see, it's all green at this time at 4:44 p.m. And it's also probably because of the pandemic as well. Like not a lot of people are going outside. Okay, so that's streets. Next, we have traffic calming measures. So what if you want to slow down the traffic movement? What kinds of interventions can you do? So this falls more on the town planning and city planning practice, not so much architecture, because this is a public space. Architecture and architects mostly deals with private space, like inside the lot. So these interventions would typically happen in the road right of way. Like this includes sidewalks and the vehicle like road itself. So you have things called neck downs, bus bulbs, roadway narrowing, pedestrian refugees, bike lanes, etc., etc. I won't go into this as much because I can give you the copy. Anyway, the idea is if you put like obstacles, it should and reduce the lane width. It will force the vehicles to drive slower because like it's more tighter. But that's what you want to do. You do these like at areas where there's more pedestrian traffic than vehicle traffic. So going back to your site, this area here, Bilaran Road, you see there's a pedestrian lane going to FGU, the FGU center. So it might be good enough if you notice that you feel like traffic is moving too fast. But I think here, for the most part, when I last visited this like couple weeks ago to do some shopping, traffic is not so much a problem here. So you can like if you could like ignore that if you're not interested in that kind of what they call this data for your building, or if your building is more towards like building materials and less towards kind of external factors. But that can also be a possible research or like point of interest for your design. So the goal really of architects is to bring all these different factors together to create a more holistic, more complete building. So it's not just like looking at your lot only, but you're looking at the surrounding area. Okay. So next. We have a nice sketch or drawing of like what a traffic calm boulevard is. Basically, this page describes how before there weren't these like islands or like pedestrian shelters, and it was all streets. So they noticed that more people were able to walk, the number of accidents went down, etc., etc. And then this is something I really wanted to show you guys because I don't think I've seen this like image anywhere else. Like maybe some drawings of this exist on the internet, but this is very well done. Like what's going on underneath our streets? Typically, you have the drainage here, and it would connect to the city like sewage system. So it would connect like this, and then you have the kind of public sewage system. And typically, these are supposed to be made before the road is made. But the problem with Cebu is like, I think the roads were made in the 70s, even earlier, like in the 30s, and nobody really kept track of where all the city mains are. They just kind of left it as is for the past, I don't know, almost like what's 1930? Let me bring out my calculator here. Let's say 1930s, before World War II. 1930s minus 2021. It's almost 90 years old. I think there's some records there, but I attended a webinar with I think the Metro Cebu Foundation or group, and they said that a lot of the existing sewer mains have not been documented, or if they were documented, the documents have been lost, so they don't know where the pipes are. So that's very troubling. In relation to your design, you need to know where the sewer systems are, or the sewer lines are, because you want to know where you're throwing your sewage, because you have like people using the public toilets, not also just the toilet water but also rainwater runoff. You might want to harvest that for like more sustainable activities, like you can reuse water to plants, to water your plants in your building, or if you're going to have like a green roof or any kind of green infrastructure, you can reuse rainwater for those purposes and reducing the water consumption for your building. Over here we have like street defects. How do like potholes form? Usually they start out as ponding, basically like unlevel, not flat and not like well-made surfaces of the streets. That causes ponding to occur, and from ponding you get like cave-ins or like potholes, etc. Manhole covers, there's not much. If you notice, I don't think I've seen a lot of when I've been driving around. A couple of weeks ago, I went to Basilica del Santo Niño for research. I don't see much potholes, so I really don't know where our sewage systems are. Old utility cuts. You see a lot more of these in like the more developed cities. Like I saw a bunch of these in Sydney, and for those of you who are in different countries, you might notice those as well. So there's an interesting diagram here of how potholes are formed, especially for cities that have experienced like all the four climates, like winter, summer, spring, and fall, etc. So this is more. They are even more susceptible to potholes than tropical climates like the Philippines. And then over here is a diagram of how smooth New York City streets are. So they're looking at they have their own measurement of percent of blocks rated acceptable. So 50 to 59% is bad, and then 80 or more is good. So you see a bunch of areas here they would consider as not smooth or like needs like a refinement. So this is interesting to note because we think of developed countries as having no problems, but there are constantly problems in cities, not just in the Philippines, but also abroad. It's really what kinds of systems are in place, like whether they be public or private organizations that are monitoring and evaluating these types of problems in the city. And we have street signs. There's a lot of those in Cebu. Some of them are not accurate anymore, or they've been like forgotten. They're just left there. And of course, the more interesting one, street trees. So these are being done by what do you call this? GIS, Geographic Information Systems. You have surveyors who track the growth of these trees, making sure like what's going on actually in the city. So I think this is street trees is something that Cebu province has a lot more than New York, I think. So if we go back to Cebu City over here, let me turn it off. And I think satellite would be better. Let me just turn off the labels. You see there's a lot of green in Cebu City. And then we have our mountains over here. So if we compare that to a satellite image of New York, which we can do, let's just go to New York real quickly. This book was published in, I think, the 2000s, so it's not updated as much. So let me just turn off labels and traffic. Off. Okay, there we go. Excuse me. So you see here the outline of New York City. And already just looking at the satellite, you see it's mostly pavement and not as much green anymore. They have like Central Park over here, Prospect Park, and they're very important for New York because they don't have a lot of green infrastructure. And there has been a lot of studies. Now, I say a lot, but I only heard of a few, like one or two, especially in webinars, where green infrastructure and like just basically the seeing of vegetation inside the city has like a lot of positive psychological effects for city dwellers. So let's go back to Cebu City. Okay, back there. Okay. Next, we have types of trees. They also like take note of that. Pedestrians. So this is something that Cebu City has a lot of, but we don't have sidewalks. There are a lot of people, like especially walking up and down the streets of Cebu. Let's say the Talamban area. Let's go look at San Carlos. San Carlos. Nakaabot pa ba mo sa San Carlos or wala na?
Yes, sir. Kaabot pa.
Nakaabot pa. It's really the first years who have never been to San Carlos, Jud, because of the pandemic. Okay, so luckily we have some sidewalk infrastructure in front of San Carlos and also um, uh, adjacent to San Carlos. The challenge here is that our sidewalks on the more commercial side is like intersected or crossed by vehicle ramps because that's the number one mode of transportation in Cebu, cars. So this would be a little bit frowned upon by Europeans and like Westerners because this is not comfortable to walk on, especially because it's at an angle. So what would happen here is that they would try to control at least the entrance of the vehicles and not make the entire front of the commercial area parking. But because of the limited space and the way Filipinos are, just like a culture thing, there's really no way to like stop business owners, landowners to just convert the front of their lots into a vehicle ramp. Ideally, there should be no kanang what they call this gaps or missing sidewalks to improve like the level of service, and that's what's being described here. Grading pedestrian traffic. There's a thing called the level of service or LOS, and then at least in New York they quantify it as LOS A, B, C, D, E, and F. And then different areas need different levels of service. And then for some specific areas, you might want a smaller level of service or like you want, no, sorry, that was wrong. Typically you want like A and B level of service where it becomes more congested. People would find it less comfortable. I was thinking of like wanting more people to visit your site, but typically, if it's easier to get your site, then it would be more attractive for people to go there. If it's difficult to go there, less people would go there. So that's kind of like the logic that I was like tripping myself up with. So there are five levels, like no, six levels of service. This is just for New York. There could be different categories for different places. For Cebu City, I think we're just starting out for something like this, but who knows? Maybe in your other provinces, your government has already started with this kind of research. And then something that developed countries have and developing countries like the Philippines don't have is the subway. I think in Metro Manila we have the Manila Rail train, but I think for the rest of the Philippines, I don't think there's any other place with a train station. But that could be just my limited knowledge. Coincidentally, Cebu City had a train station, but it was destroyed in World War II. There are images you can, if you just Google like Cebu City train station, there you can see images from like the 1920s and 1930s, and then that's pretty much it. They didn't revisit it. The existing or the train station of the past are now like malls and like commercial buildings today. So they just built on top of that railroad. It's kind of unfortunate given how the traffic situation in Cebu has just worsened, and then that train station could have been very useful. Anyway, this is just a comparison of the subway networks in New York. Yes, go ahead. Is that my question? Wala din. Okay. So we have here New York. Notice how it's like more longitudinal, like one way, and not so concentric. Tokyo has more concentric setup. Moscow as well. And this impacts the number of people who use the service. Hello? Is someone using their microphone? Accidentally using their microphone? Let me just check. Where's it coming from? Ah, it's here. Sorry, Colleen. I'll just mute you for a second. Mute. Okay. And anyway, I just wanted to highlight this because the more concentric, not just your subways, but also your street and like road networks are, the easier it is to use, and more people will use them. So compared to Moscow has 3.3 billion passengers per year in their subway, Tokyo has 2.7, and then New York has only 1.4. And I think a big factor here is the way it's arranged, because it only goes north, south, east, west, and not like in a concentric center, more north, south, and not so much east, west directions. And then you have London here at 886. And notice again that linear pattern. So it doesn't have that concentric pattern here. I think geography would have like a big factor in determining the transportation infrastructure of a city, and this is really kind of the challenge of Cebu province, because if you look at our map over here, let me just zooming out again. Cebu City has a geographically is like very linear north south development, not so much east west, because we are divided by our terrain. So this is unbuildable land, if you can see. These are our mountains, very good for what they call this, absorbing rainwater runoff, but very bad for transportation infrastructure. So really have no choice but to develop north south, and like not so much connections east west, because when we do, we have to cut through the mountains, which is very difficult and also very bad for the environment. Okay, next. This is just looking at the number of people per hour. That it's unfortunate that I got the time sort of blurred, but I can ask for like I can take a picture of it, because scanning it is very difficult because it's a very thick book. Markets, very important to note for cities as well. Where are people buying and selling goods? Your building, your commercial building, will fit into this category. So let's go back. So we're here. Ayala, where it says. So your activities inside your building are banking, retail, and offices. So typically, this would be a space where people work. And then where are your kanang workers coming from? So if you think of a banker, a retailer, and an office worker, you would think of like someone in their at least somewhere in their 30s to 40s range, professionals, and young professionals like somewhere between like early 30s, like late 20s, early 30s. The managers are somewhere between like 50s and 60s. So these kinds of people, you already have like an imagination of where they might live. So they would be middle income or high income if they're managers. So you just need to take a look at where are the residential areas in Cebu. So the high income residential areas would be typically in subdivisions. So just take a look here. So this is a very medium to high end subdivision next to San Carlos. And I think this is Maria Luisa. No, wait, what's the subdivision called? Doña Rita. So these are the kinds of houses where managers and like office workers might live. And then with that kind of like information, or just like knowing that, you can estimate that it might take them like, let's say here, Doña Rita to Ayala Terraces. Directions. Doña Rita. Doña Rita Village to Barangay Santo I don't know, Ayala Terrace. So it takes them about 11 minutes if they left now, but probably will take them 20 minutes or 30 minutes if like there's like traffic, or like pre-pandemic times, it might even take them over an hour to travel that kind of distance. It's only 4.2 kilometers, but the traffic congestion in Cebu City is really bad. So you already have like an idea of what kinds of people are using your building, and then you can use that data to influence your spatial design. So if you're designing for someone who's like in his 60s, you don't want to create like very narrow hallways. So you want to make the hallways comfortable, so you make the hallways wider than the standard. So let's say if the standard is 1 meter, so you might want to make it 1.5 just so it's comfortable for your clients and users. And if they're happy, that means you get paid. basically. Okay, so that's how you can use this kind of data to create better buildings. Okay, moving on to the next factor. These are the different market areas in New York. You can and then the next one over here is power consumption. So electricity, and then I just recently realized that electricity is not really a clean source of energy, especially in older cities. So if you look over here, this is New York City, number of customers at 2 million with 11 million megawatt hours of power consumed. This is Rhode Island, another city in near that area, I guess. I don't know where Rhode Island is, but it's an American city. The number of consumers at 400,000 and megawatt hours is a lot less compared to New York. And notice that New York is significantly smaller than Rhode Island. And then over here, you have Michigan. So you can fit like hundreds of New York cities into Michigan, and their power consumption is surprisingly a lot higher. So it really depends on the kinds of people or the behavior of people living in that area. So it seems like geography doesn't play a factor, like the size of the city, doesn't really play a factor in the power consumed. So you see, as number of people increase, power consumption also increases. So you can create like some kind of conclusions from there. With regards to your project, so this is a retail, office, and bank building. Typically, it should be open. At least most of the power use is like in the 8-hour workday. So you're thinking about how do I reduce electricity consumption? Think about natural ventilation, natural lighting. Since most people are working in the day, you want to take advantage of as much natural light as possible so they don't need to turn on a light bulb, and then you can reduce power that way. Some of you might be asking, how is power generated? So let's just power plant uh, process. So why is power not like electricity not green or not kinda sustainable? Because most of the power plants, even in Cebu City, I think we have two. They get their energy from coal. So they burn coal, and the heat that comes from burning coal turns a turbine, and then the turbine, uh, that spinning action creates electricity, and then that's where they transfer that spinning action into electricity with a generator. That generator harvests that electricity and sends it to a transformer into the transmission lines. Also, you have because that spinning causes a lot of heat, you'll need like a cooling tower, and then the cooling tower needs to be cooled, so they need to get water, usually from a reservoir or a lake. So this is a plant, Scherer in Georgia. I think this is an American plant. So if you quickly Google Cebu City power plants, which I will do here, I think we have a couple, and then you'll notice that they're mostly coal powered. So burning coal, you're creating so much CO2, so not environmentally friendly. So that's why we want to reduce our electricity use by taking advantage of natural lighting, etc., etc. So let me just click on images here so you have like an idea. So this is what a power plant looks like. This one is in Toledo. This one is in Naga. So there are power plants. So I've this is just something to like help you visualize. Okay, next one. We're almost done. After electricity, we have water. Oh, this is also an interesting graphic, just like measuring how much wattage each appliance uses. So we have like 15 watts for electric shaver, 1000 watts for your hair dryer, 60 watts for your lamp, 30 watts for stereo, a clock, like plug-in clock. I think most of our clocks are battery powered. Computer uses 200 watts. I think this is per hour. VCR 40, etc., etc. So I'll send you guys a copy of this for your like consumption. Okay, let's skip to water because we're running low on time. Oh, I almost forgot. This is why alternative energy sources are becoming more and more popular, because the current way of harvesting electricity is very kind of harmful to the environment. So that's why your people are switching to biomass And over here we have wind energy, solar energy, hydroelectric using the powers of like waterfalls and dams. So something like that. Definitely a lot more environmentally friendly than the coal power plants. And then over here we have distribution of how you get your electricity from a power plant to your house. Might be interesting for you. And how does this affect your building aside from like the need to reduce an electricity consumption? You might want to install some solar panels in your building. How will that work? Um, I don't know if wind harvesting is feasible in Cebu City, which should be like interesting because we're in a tropical climate and we have like a lot of like especially during the monsoon seasons, we might be able to harvest some wind, but there's no research on that. So that's how you can make your building, your designs more innovative. I don't know which one is the correct pronunciation, but that could be an interesting like thesis topic for you guys if you're interested in that kind of thing. Anyway, moving on. So that's power. It's a diagram of like water. So where is the water from New York coming from? So they have a bunch of reservoirs here. So there's a Delaware system of reservoirs, the Catskill system. Basically, they get it from uh, lakes that naturally run through in the landscape, and then harvest that and put it through a kanang what do you call this? Yeah, reservoir. There's no other word for it. So what do reservoirs look like? Let's just like very quickly look at Cebu City reservoir. Did I spell that right? We have the Buhisan Reservoir. Can we see? It's covered in trees. So it's all the way up there in the mountains, and that's the gate for it. The Buhisan Watershed Forest Reserve. But let's try to see if we can actually see the building. Okay, so what does that building look like? Because it could be like oh, you see the dam there. So it's just a dam, and I think some support structures along the way. Because this could be interesting for thesis as well. With regards to your project, however, I think the main point here is to use as little from the kanang from the tap, like you're tapping into MCWD or whatever your like local water source is in your different provinces and cities. Um, the idea is the harvesting of rainwater and like reservoirs takes time, and if we consume too much then we harvest, then we'll run out of clean water, which is something that Cebu City is like having troubles with because like there's increasing population and then the supply can't keep up. So it's basic supply and demand problem. So if we can harvest clean water somewhere, if your building itself can reduce water consumption, then that will help. Like if each building reduces their water consumption, in the big picture, you could save like hundreds and thousands of gallons of water per year. So that's why it's important to include what do you call this water management systems in your building, both potable and non-potable. Okay, so this is what it looks like, at least in New York. We have something similar in Cebu, where the rainwater lines are supposed to be underground, and not rainwater, sorry, potable water lines are supposed to be underground, and they're like pumped into the buildings. You would see this in Cebu City that our drinkable water lines, potable water lines, are already on top of the street. You would see something like this street, Waterline Cebu. Now, not really this, but let's see. Anyway, if you could just imagine that for those not in Cebu province, that they would see running pipes, especially the blue kinds. Those are the potable water pipes. And because our population was increasing or is increasing at such a great rate that the system can't keep up. So we have these like ad hoc, meaning impromptu setups where we just tap from an underground water line and then bring it above ground because the family is already living there and they need water and they pay the taxes and whatever, all the fees. So the road system, the street system, and the water system are not being coordinated properly. So you have these kinds of problems. So that could be one issue that you can tackle with your design, like especially since we're drawing the schematic diagrams for potable and non-potable systems. Water tanks, a good way to supply water, like to harvest and supply water in your building. Notice that the pressure from the water tanks increases the greater the distance. I think that's like common sense. So if you live on the 10th floor over here, the water pressure is a lot less compared to when you live on the first floor if you're taking water from the water tank. So it's like you're just letting gravity do the work. Okay, and then you have like a pump here, like maybe they're getting water from their local line and they pump it into the tank over here. That's why you need the pumps here. Okay. So that could be one system for your building. And then if you research that, that would make your design much more valuable and interesting. Okay, so some consumptions here. Washing machine uses 56 gallons of water to complete an average load. Your toilets uses 6 gallons per flush. Dishwasher 24 gallons per load, etc., etc. I won't go into too much because like we're kind of short on time because I need to discuss another topic for this week as well. Okay, wastewater collection. So similar to what we saw with the water supply, supposedly or ideally, the sewage system should be running along our road network, underneath the road network, because this is the main public space of the city, and then collecting it from the what do you call this? The stormwater drains. We're supposed to have manholes. Manholes are there for people to go in and check the system, but that's not so much happening in the Philippines, unfortunately. And then you see the drainage system from the toilets and the lavatories connecting to a septic tank, and that septic tank over here on the left connected to the main system. And the main reason, I keep saying main, why septic tanks in the Philippines and in Cebu in particular are not connected to the sewage main is because we don't know where the sewage main is. And then there's also that fear that we are overloading our sewage system. Just take a look at the previous image over here. Um, this is the main problem of a lot of places in the Philippines. Pollution of our local lakes, rivers, etc. We have trash there, all of our waste is there. So that's why our septic tanks typically don't connect anymore to the sewage system because frankly they are overloaded. So you will discuss more about how septic tanks work in your Utility 1 classes. I'm sure you have taken that. And just like a quick overview, septic tanks have two chambers to digest or like break down the different sort of particles in there. And then this is one thing you can include in your design for your office building, the catch basin. So this is one way to sort of hold rainwater, and you can harvest this or you can just like hold it and then toss it into the system. The idea is if you hold more rainwater, you give the drainage system of the city more time to absorb like rainwater. So example scenario is like it's typhoon season, magbaha, permi, flood, there's like flooding in the streets. If your building can absorb at least like a fraction or some amount of that rainwater, it will help the system handle flooding. So if all buildings in Cebu had proper catch basins, maybe it wouldn't flood as much. But that could be one challenge you can look for. So different grating types, grating details that you can show in your design. So that will be interesting as well. And then over here, catch basin hooding. So we're really thinking about what happens when the pipes get clogged. So if you have this kind of hooding or like a shield, it prevents like all these like big bottles, plastic, whatever, from entering into the main exit over here, and that just prevents blockage. So you could do something like that. And then finally, we have the sewage treatment plants. I think this will be the last system. So how do we process that waste? There's, I think, a few sewage treatment plants in Cebu City, but not enough because you look at our pollution over here. The idea is it's basically a facility that's a huge septic tank. So it's digesting all the different waste, making it like from toxic to like something which they call gray water. It's not drinkable, but it's a lot cleaner. It won't kill it won't cause harm as long as you don't drink it. So you have the different chambers here. You have the kind of what is it? Upon entering the plant, wastewater is pumped through the bars, must screen ang debris, all the newspapers, plastics, basically just filtering the water until it becomes cleaner. And I can send you like a photo of this if you want more data. But like if you Google sewage treatment plants, you should come up with something similar. I just really like this book because it places everything into one book. And then, oh wait, one more thing. Where does the garbage go in the city? So we have uh, the garbage facilities or the landfills and also materials recovery facilities or MRF, which sort of like supposedly we segregate the trash, we separate what's recyclable and non-recyclable, and we have like this is a luxury in developing countries street cleaning systems, which we don't really have much. We have the manual street cleaners, the people with the brooms. So New York, you can really tell it's like above and beyond, or one of the most kind of developed cities. Not the most livable, which we'll discuss like a few weeks from now, but they have all these systems in place to clean up not just their water but also their trash. And that's all 42 pages. And this is the first half of that of this lecture. So I think I'll stop recording here so it's easier for me.